It's Quadratic Inequalities, part dos. So there are two more problems that I wanted to talk about with the quadratic inequalities. Not that I think they're that much more difficult, but they are different, and so I want to address them to make sure you are comfortable and confident with dealing with those. Problem number 4, it's a special kind of treasure. We've got the left side of some kind of quadratic that's in factored form. We have the right side of some kind of quadratic that's in factored form. And unfortunately, while I normally like factored form, I'm going to need to unfactor this. I'm going to need to multiply it out because this is not in standard form. And so it's really difficult to find the critical values when it's not in standard form. And so we're going to need to do some multiplication here. So what we're going to do is we're going to take this left side, multiply it out. So we've got 2x squared, let's see, minus 4x plus 5, so plus x minus 10. All right, that's greater than. I'm going to do the same thing on the right side. I'm going to multiply this mess out. So let's see, x squared minus 3 minus 2, so minus 5x plus 6. Now, okay, I'm going to take everything from the right side and move it to the left. That will create the standard form for me. It'll create a 0 on the right side that I also want. So let's see, minus x squared plus 5x minus 6. All right. And because we were doing just simple subtraction, nothing gets affected with the inequality. All right, so let's see, x squared plus 6x minus 16. All right, let's factor this thing. So what am I thinking? Plus 8x minus 2. All right, critical, wow, I don't know what I was just trying to write there. I think I added way too many little letters there. Okay, critical, there we go. Critical values. Let's see, that would be negative 8 and positive 2. All right, so number line, I am going to label my two critical values, negative 8, positive 2. Okay, and now I want to pick test values. So any number less than negative 8, I'm going to pick negative 10. I always like being able to pick 0 if possible. And any number greater than 2, I don't know, I'll pick 4, okay? So what I'm going to do is I'm testing this again. Go to the original problem, okay? And you are going to test negative 10. Now this one I'm actually going to show you. I normally don't, or on that last one didn't show the test, but I'm going to show it here, okay? It's just so you understand. If we are testing negative 10, what does that mean? So we're going to do negative 10 minus 2. 2 times negative 10 plus 5 is greater than negative 10 minus 2 and then negative 10 minus 3. Okay, so I'm going to put this left side in my calculator, okay, the whole thing, it's fine. So let's see, 2 times negative 10 plus 5. All right, so this mess turns into 100, nope, I don't know why I just put a negative, hold on, 180, okay. Then I'm going to put this right side in the calculator, okay, so negative 10 minus 2, negative 10 minus 3, this turns into 156, okay. So now the test is 180 greater than 156? That is 100% true, so that means I've just tested all the values less than negative 8. So all of these values I now know are true. Okay, that one test tests the whole interval. Okay, I'm going to test 0, and I'm going to do the exact same test. Okay, everywhere I have an x in the original problem, I am going to replace it with a 0. I'm going to test the left side against the right side and see what happens, okay? So let's see what we've got here. We're going to have 0 minus 2 times 0 plus 5. All right, this turns into negative 10 is greater than On the other side, we've got 0 minus 2 and 0 minus 3, so that's 6. So we have a statement that says negative 10 is greater than 6. No, it's not. All right, false statement. So that tells me that the numbers between negative 8 and 2 do not work. I want to test 4 and see what happens there. So test 4. All right, 4 minus 2, 2 times 4 plus 5, greater than 4 minus 2 and 4 minus 3. Okay, so same thing. All right, this time we're going to work with 4s. Again, you could pick any number greater than 2 if you wanted to test 3 million. Go for it, all right? I tend to test smaller numbers so I don't get weird things happening in my calculator, but you can do you. All right, so the left side turns into 26. The right side turns into 2. So I have the statement 26 is greater than 2. That is 100% a true statement. So that's going to test all those values greater than 2. Last thing to check for, bracket or parentheses here. This was strictly greater than, so I'm going to use strictly parentheses on my critical values. So interval starts at negative infinity, goes to negative 8. One quick note, please make sure that your infinities and your 8s don't look the same. Some people have hard time drawing infinities. If that includes you, practice it first of all, but you can also just draw, that looks a little bad, okay? You can basically draw something like that where it's just 2 circles next to each other, if that would help you, all right? But basically when I start seeing things that look like, wow, that was really bad, but things like that, that looks like an 8 to me, all right? So make sure your infinity is an infinity symbol. Okay, enough of that. Problem number 4 is done. We've got our interval. We've got our whole thing figured out, critical values, the whole bit. All right, I am going to slide on over to problem number 5, and let's see what happens here. All right, so same thing. I want to multiply out the left side. I want to multiply out the right side and see what kind of quadratics I turn up. So let's see, 2x squared plus 8 minus 1, so plus 7x minus 4 greater than or equal to 2x squared minus 6 plus 1, so minus 5x minus 3. And I am a seriously happy camper right now, and here's why. I immediately recognize that this is a 2x on the left side, and this is a 2x squared on the right side. They match. So conveniently, I can subtract them from both sides, and you no longer have a quadratic equation. You have a linear inequality here. Okay? So if this is a linear inequality, this is the same thing we've been doing for a long time now, right? We're just going to solve the inequality. I'm going to go ahead and add 5x to both sides. I'm going to add 4 to both sides. Okay? So let's see, 12x is greater than or equal to 1. Divide both sides by 12. I'm dividing by a positive, so I don't have to worry about the inequality sign shifting. Okay, it doesn't move at all. So I don't really have a critical value here. I just have an inequality to graph. All right, because it specifically says x is greater than 1/12. So that's going to be all of these values greater than or to the right of 1/12 here. And the last thing to pay attention to is bracket or parentheses. There is clearly an equals to sign here. So we're going to use a bracket. And so my interval here is 1/12 to infinity. If you are unsure, feel free to test. I would absolutely test 0 and then test 1. Those are relatively easy to work with generally with these problems. Okay, so I hope those problems make sense. Again, they're not terribly difficult. They're just different than the first 3 we had done. So as always, if you have questions, send me a message. And if you want to request anything else in terms of quadratic inequalities, send me a message with that as well. I hope this helps.